Hello everyone, I welcome you all to Startup Academy, your online gateway to get success in ISS exam. This academy is exclusively for ISS and we have been covering the topic of time series which is of statistics paper 3. We have covered almost all of the time series. We started with advanced time series. Today we'll start with a new topic which is auto-regressive model. So in auto-regressive model, what is auto-regressive model? A model where a time series model which depends on its previous times. Suppose we are taking a model, a time series xt. So when it depends on xt minus, we are taking beta naught plus beta 1 x t minus 1 plus beta 2 x t minus 2 up till beta p x t minus p plus wt, where wt is nothing but white noise having zero mean and sigma square variance. In times, as in the econometrics model we have the error term, in time series model we have the white noise term. So whenever our model depends on the previous p values of the model itself, then that series or that model is known as auto-regressive model. Now this model can be converted to, if suppose we are taking backward difference factor. B is, let B be the backward difference. So xt would be taking all the terms of relating to xt on the left hand side, beta 1 xt minus 1 minus beta 2 xt minus 2 up till minus beta p x t minus p is equals to white noise. This can be taken as backward. Backward difference is nothing but, if I am taking backward difference of xt, then this is x t minus 1. If I take it backward different raised to the power 2, then it would be x t minus 2 and so on. So I can write it as xt minus beta 1 backward difference xt minus beta 2 backward difference whole square xt up till beta p backward difference raised to the power p xt is equal to white noise. Now xt can be taken common from all of them and we are left with 1 minus beta 1b minus beta 2b square up till minus beta p b raised to the power p is equals to wt, and this can be written as xt bracket beta is equals to wt. So this would be our backward difference model. Now, there are two conditions of any model. First is we need to check for its invertibility, whether the model is invertible or not. So, if our model has beta t is less than infinity, then this model of autoregressive series can be termed as invertible. And if the second case is whether our model is stationary or not. Our model is stationary when the roots of this equation beta p, roots of beta p is equals to 0, where beta p can be written as 1 minus beta b minus beta square b up till so on minus beta raised to the power b 0. Suppose we are getting roots z1, z2, z3 up till zp are or lies outside the unit square. Then only our model can be termed as stationary. So for invertibility, our the measurement of invertibility is when the modulus of bt or the series which we have calculated is less than infinity, or for stationarity when the roots of this equation bt or bp, whatever you say, lies outside the unit square. Then only this can be termed as stationary and invertibility. So for consideration, let us take first one, AR model 1, auto-regressive model of order 1. This is also written as AR1 model. AR1 model can be stated as y xt is equals to phi x t minus 1 plus wt, where wt is again our white noise 0 comma sigma square. So this is the autoregressive model of order 1, where the time series data only depends on the one previous value, and phi is any constant which is related to that value. So here let us take those equations also. Xt minus phi xt minus 1 is equals to wt 1 minus phi b xt is equals to wt. So the model will be stationary when the roots of this equation 1 minus 5b is equals to 0 lies outside unit circle, and the model will if the model will be invertible, the AR1 model will be invertible or is invertible if the modulus of that equation 1 minus phi b is less than infinity. So invertibility and stationarity both we have done. Now we'll move forward to this model only. Let us take the model xt is equals to phi x t minus 1 plus omega t. Now xt minus 1 can again be written as, if we iterate the model, iterating the model. Iterating means repeating the model. If I take xt minus 1, xt minus 1 can be written as phi x t minus 2 plus wt. This can be written as phi square x t minus 2 plus phi wt. And so on. If we keep on iterating it like this, we'll get xt as summation of j goes from 0 to infinity phi raised to the power j x t minus j. So this would be our time series model, or AR model, we can say this, under iteration. If we take n number of values or infinite number of values, then this would be our model. Now, what would be the mean, variance, and auto covariance of these models? We'll calculate mean of the model. So for mean, we'll take, the model is given as xt is equals to summation over j goes from 0 to infinity x phi j x t minus j. So if we take mean, mean would be estimation of xt. This would be summation j goes from 0 to infinity phi j estimation of x t minus j, which would be nothing but equal to 0. This would be the mean of it. Here for instead of x, that it would be w. Since we know that wt belongs to white noise with mean 0 and variance sigma square, so therefore our estimation of wt minus j would also be the same, which is 0. Now what is the autocovariance function? Second one would be autocovariance function. Or it can also be written as ACVR. Autocovariance would be covariance between xt and xt plus h. Xt was given as summation of, so it can be written as covariance between summation of j goes from 0 to infinity x phi j wt minus j and summation of s 0 to infinity phi s w t plus h minus s. This can also be written as estimation of phi w t minus wt plus phi w t minus 1 plus phi square w t minus 2 up till so on till infinity, and 1 plus phi w t plus h plus phi square w t plus h minus 2 up till so on till infinity. So estimation of this would be nothing but sigma square summation of j goes from 0 to infinity phi h plus j into phi j. This would be nothing but sigma square into phi h. J goes from 0 to infinity phi 2j. Now this is our geometric series which can be expanded as j goes from 0 to infinity phi 2j can be written as 1 plus phi square plus phi raised to the power 4 up till infinity. And the sum of a geometric series is a upon 1 minus r, where a is the first term and r is the ratio, common ratio. So a would be here 1 and r would be phi square, 1 minus phi square. And hence our ACVF, which is covariance between xt and xt plus h, would be sigma square phi h upon 1 minus phi square. This is the covariance of or autocovariance function, which can also with lag h, which can also be termed as gamma h. Now the second one would be our auto correlation function, or it can be written as ACF. Now we know that autocorrelation is nothing is represented by rho h, which with h lag is nothing but gamma h, which is auto covariance function with lag h upon auto covariance function with lag 0. Now of putting the value of lag as 0 in the before equation, sigma square phi raised to the power 0 upon 1 minus phi square, which is nothing but sigma square upon 1 minus phi square. And lag h, we all know autocovariance with lag h is nothing but sigma square upon phi h 1 minus phi square. And hence we can calculate autocovariance function with lag h, which is nothing but keeping the values here, we get sigma square phi h upon 1 minus phi square whole upon sigma square upon 1 minus phi square, which is nothing but phi h. So this gives you the autocorrelation function of AR model 1. And this completes our for all h. We can write for all h goes from 1 to up till infinity. So this completes our auto-regressive model of order 1. I hope that you understood whatever we have done today in the class. And if not, then you can ask in the comment section or on our WhatsApp channel. All your doubts will be cleared. And if you still have any doubts in any of them, then you can rewatch the past videos which we have uploaded. All of the main things have been discussed in the previous lecture or the first lecture of the advanced time series. And keep on working hard with the clear mind that you have to achieve the goal this time only in 2026. All the best. Thank you.